This content will be useful for all civil engineering competitive exams as well as the college semester exams. We are going to discuss about the turbidity of water, which is a physical quality characteristics of water. Other physical characteristics can be color, taste and odor, and temperature. Quality characteristics of water can be divided into physical, chemical, and biological characteristics. Total solids it's determined by rating the sample at 10 and 5 degrees Celsius. Fixed and volatile suspended or dissolved fraction can be obtained by heating the solid at 550 degrees Celsius in muffle furnace. Disposal of treated wastewater under the acceptable limit for suspended solid is 30 milligrams per liter. These are few data which should be remembered clearly because it has been asked a few times in the competitive exams. Turbidity. Turbidity is the suspended and colloidal sediments such as silt and clay and organic matters such as algae, plankton, etc. Turbidity of water is based on light absorption and scattering, which is influenced by the size and surface characteristics of the particles. Only suspended particles are considered to cause turbidity. Dissolved solids causing opacity in water is measured under color. This is a clear distinction between turbidity and color. These two are the physical characteristics of water. Increase in turbidity leads to decrease in the photosynthetic effect, which provides lesser oxygen. Thereby, oxygen available for oxidizing metals for organic matter will become less. This is a very big problem which the turbidity causes to water. So it has to be kept in acceptable limits. The suspended matter can shield the microorganisms from disinfectant and organic suspended solids. We consume disinfectant oxidizing agent for its solution, thereby reducing the disinfectant available for pathogen killing. Turbidity is measured using the following methods: turbidity rod, Jackson turbidity meter, Baylis turbidity meter, and nephelometer. Let's discuss about these ways of finding the turbidity. Turbidity rod. Rod with platinum needle is inserted inside water, and the depth at which platinum needle just becomes invisible gives turbidity in ppm. As depth of insertion increases, reading will decrease. This is a very important point. That depth of insertion increases, the reading will decrease. This can be asked in assertion region type of questions, which is usually asked in engineering services examinations. Jackson's turbidity meter. The level of water is increased till the image of flame ceases to be seen. The turbidity is measured from graduated glass tube. It is used when turbidity is greater than 25 ppm. It is a laboratory method. This method is not used for drinking water. These are the few important points in Jackson's turbidity meter, that it is not used for drinking water, and it is also used when the turbidity is greater than 25 ppm, and it is not a field method. It is a laboratory method. These points should be remembered. Baylis turbidimeter and nephelometer. Baylis and nephelometer turbidimeters are based on color matching techniques. In this case, even a small turbidity of 1 unit or less can be measured. Hence, these are most widely used for domestic water supplies. This is an important point. It can be asked that which one is used for domestic water supplies. We have to give the answer as Baylis turbidimeter and nephelometer. In Baylis turbidity meter, light intensity is measured in the direction of incident light only, whereas in nephelometer, light intensity is measured at right angles to the incident ray. This gives the distinction between these two processes. Hence, NTU is based on the scattering principle. If for meson, a chemical is used as a base in place of SiO2, the turbidity unit is also sometimes called FTU.